Hello friends. So we have a question with multiple parts involving derivatives and various series. So in the A part, we have been asked that we have to find the Maclaurin series for this function fx up to the term x to the power 3. So what is a Maclaurin series? In Maclaurin series, we have to understand that any function fx can be written in the form of a series. So here fx can be written as f of 0 divided by 0 factorial plus f of f dash of 0 into x divided by 1 factorial plus f the second derivative of f dash at x equals to 0 multiplied by x square divided by 2 factorial then f dash 3 of 0 multiplied by x cube divided by 3 factorial and so on up to infinity. So any function fx can be written in this format. This is the Maclaurin series. Now, once we know this, the question becomes very easy. So we have to identify the Maclaurin series for the fx e raised to the power x multiplied by sine x. Now there are two ways in which we can attempt this question. First is we can identify the Maclaurin series for e raised to the power x. This is f of 0, which is e raised to the power 0 is 1. 0 factorial is anyway 1 plus f dash 0. The first derivative of e raised to the power x is e raised to the power x, and when we put x equals to 0, we will get again 1 into x divided by 1 factorial plus f double dash 0, that means again e raised to the power x, so we will get 1 again x square by 2 factorial and so on. In the same manner, you can identify the series of sine x. In fact, you can remember these series. These are important series. And we will get x minus x cube by 3 factorial plus x raised to the power 5 by 5 factorial. In the exactly same manner in which I have identified e raised to the power x. Now, we can multiply these two series, and in the question it is said that up to x cube. So when we multiply these two series, the first is 1 plus x by 1 factorial plus x square by 2 factorial and so on. And in the second term, I will rewrite x cube by 3 factorial plus x to the power 5 by 5 factorial. Please remember, I have not written the x cube term here because I have to find the values. I have to find those terms only up to x to the power 3. So the term here x to the power 3 will become x to the power 4 when it is multiplied by x. So it will not be of our importance. So when 1 is multiplied here, it will get x. When 1 is multiplied with the second term, we will get minus x cube by 3 factorial. And after that, the power of the x will be greater than 3. So those terms are not required in this question. Now let us move on to the second term. When x is multiplied with x, we will get x square. And when x is multiplied with x cube, we will get powers higher than 3. So we are not interested in that. Again, x square is multiplied by x, we will get x cube by 2 factorial. And after that, all powers would be higher than x. They will be there, but for this particular question, we are not concerned about those. So x minus x plus x square minus x cube by 6 plus x cube by 2 and so on. So we get x plus x square plus x cube by 3 and so on. You can also try this question in another manner. Since we are given the fx we can directly find the Maclaurin series by identifying f of 0, which is 0, then f dash 0, because you can directly use, as we have said, any function can be written in the form of series. So we can identify f0, f dash 0, f double dash 0 and f triple dash 0. We will see whether we get the same result or not. To identifying f dash 0, we need to first differentiate f dash x. So f dash x will be e raised to the power x sin x plus e raised to the power x cos x. And when we put f dash 0, this term will be 0 and this term will be 1. Now let us try to find the second f double dash 0. To find the f double dash 0, we will have to differentiate the f dash 0 again. So what we get is f dash 0, we would get is at x equals to, first we differentiate f dash, so we get is e raised to the power x sin x plus e raised to the power x cos x, and then differentiating this e raised to the power x cos x minus e raised to the power sin x. And at x equals to 0, this term and this term would be 0, and we will get is cos x at 0, 1 and 1. So we get is 2. And since we have to identify the values up to x to the power 3, so we need to identify f as 3 also. So what we get is e raised to the power x sin x plus e raised to the power x cos x, then differentiating this plus e raised to the power x cos x minus e raised to the power x sin x, then again differentiating this. These two terms are same, so this will be again exactly similar, minus e raised to the power sin x, and the differentiation of this would be minus e raised to the power x sin x minus e raised to the power x cos x. Or you could have simplified these terms and then also you could have differentiated. At x equals to 0, these terms of sin x will be 0, this will be 1, this will be 1, 2, this will be 3, and this will be minus, so we will get is 2. So the Maclaurin series for e raised to the power x sin x will be, as you can see from the formula, f of 0 divided by 0 factorial, which is 0. Then the second term is f dash 0 into x. So f dash 0 is 1, which is x by 1. Then we will go to the second term. Second term is f double dash 0 divided by 2 factorial. So f double dash 0 is 2 into x square divided by 2 factorial, plus we will go for the third term, which is f triple dash 0, which is 2 into x cube divided by 3 factorial. So what we get is x plus x square plus x cube by 3 and so on. So this is exactly same as we obtained in the previous method. Now let us move on to the B part. In the B part, we have to identify the integration from 0 to 1 e raised to the power x square sin x square into dx. E raised to the power x square sin x square dx from 0 to 1. Now, we can use the expansion of e raised to the power x sin x in this series. In place of here, in this part, we can see in place of x, we have replaced it x square. So, utilizing the same series, in place of x, we will write x square. So what we get is x to the power 2, x to the power 4 and x to the power 6 by 3 into, and so on, into dx. So let us try to integrate this function and let us try to find what we get by the integration of this function. So this integration will be x cubed by 3 plus x to the power 5 by 5 plus x to the power 7 by 21, and limits ranging from 0 to 1. So this will be 1 by 3 plus 1 by 5 plus 1 by 21 minus 0. So adding all these we get 105. This is 3. This is 35 plus 21 plus 5. So what we get is 61 by 105. So this is the value of the second part. So now let us move on to the next part. In the next part, we are given another function e to the power x into cos x. And we have to show that the gx, a function which is e to the power x into cos x, satisfied a given differential equation. So let us see what is the function gx. Function gx is e to the power x cos x, and the differential equation it satisfies is g double dash g, the second derivative of x, equals to 2 times g dash x minus g of x. So gx is already given, to find the derivative of this, which is e to the power x cos x minus e to the power x. Second derivative would be e to the power x cos x minus e to the power x sin x minus e raised to the power x sin x minus e raised to the power x cos x. So we have differentiated this function. We can further simplify this. These two terms are exactly same. So this is minus 2 e raised to the power x sin x. So let us try to see whether these two terms are coming equal or not. So let us try to find 2 times g dash x, which is e raised to the power x cos x minus e raised to the power x sin x minus e raised to the power x cos x. So we can see this is cancelled. This comes out to be minus 2 raised to the power x sin x, which is exactly same as g double dash x, or the second derivative of the gx. So the function gx satisfies the equation g double dash x equals to 2 times g x minus gx. Now in the second part we have to comment on the fourth derivative. So from here we can identify, if we differentiate on the both sides, g3 derivative would be 2 times g double dash x minus g dash x, and if we differentiate again, the g4x will be equals to 2 times g derivative of x minus g second derivative of x. So this is what we needed to prove in our second part of C. Now in the D part, using the result from part C, we have to identify the Maclaurin series for Gx. Now for the record, let us again what is the Maclaurin series. Maclaurin series are f of 0 by 0 factorial, f dash 0 into x by 1 factorial plus f dash double 0 into x square by 2 factorial, then f dash 3 0 to x cube by 3 factorial, and we have to identify up to 4 terms. So g of 4 into x to the power 4 by 4 factorial. So what is the gx here? Gx here is e raised to the power x cos x. So do we have z of 0? Yes, z of 0 is 1. Do we have z dash 0? Yes, we have already identified g dash, which was e raised to the power x cos x minus e raised to the power sin x, and when we put x equals to 0, what we get is sin x term would be 0, so we get is 1 again. So this would be 1. Can we identify z dash 0? Double dash 0? Yes, in the g double dash 0, we can use the given equation, which is 2 times 0 minus z of 0. So this would be 2 times 1 minus 1, which is 0. Can we identify S3 using the similar equation, which would be g double dash 0 minus 0. So realize the results in the previous part, so we are using this minus g dash 0 is 1, so this is minus 2. So similarly g40 would be 2 times g dash 30 minus g dash 0. So this is 2 times g dash 3 is minus 2, g double dash 0 is 0. So what we get is minus 4. So gx can be written as z of 0. Z of 0 is 1 plus z dash 0. Z dash 0 is 1 into x by 1 factorial plus g double dash 0 is 0 x square by 2 factorial. Then z dash 3 is minus 2 into x cube by plus z dash 4, which is minus 4 into x to the power 4 divided by 4 factorial. This will be 1 plus x plus 0 minus x cube by 3 and minus x to the power 4 by 6 and so on. So this is the Maclaurin series, which was given in the part, which was asked in the part D. Now in the last part we have to identify the limit for the given function. The limit for the function, we have to identify the limit x tending to 0 e raised to the power x cos x minus 1 minus x divided by x cube. So we have already identified the expansion of this function e raised to the power x cos x. So that would be 1 plus x minus x cube by 3 minus x to the power 4 by 6 and so on, minus 1 minus x divided by x cube and limit x is tending to 0. So we can see these two terms are cancelled. This is their power x cube, so this would be minus 1 by 3 and minus x by 6, limit x tending to 0. Since x is a very small number, it will be almost equals to 0. Our limit is minus 1 by 3. Otherwise also we can identify the limit by using L'Hopital rule, where since if we put x equals to 0 or we tend x towards 0, we will see this term will tend to 1 minus 1, so this is forming a 0 by 0 format. So this limit is same as limit of a function when we differentiate the numerator and denominator. So e raised to the power x cos x minus e raised to the power x sin x minus 1 divided by 3. So again we can differentiate this, or if we tend to x equals to 0, we see this term would be 0, this term would be tending to 1, so this would be again 1 minus 1, and if we need to again apply the L'Hopital for till that indeterminate form is solved, we will get the limit minus 1 by 3. So this is your solution. For more such questions, do visit our website www.iitnacademy.com and register field solution. Thank you.